here we are on page 3 of 9.4. And some more rationalizing to finish up this section. But you might notice right away a difference here. When you look at the denominators, if you look all the way down this page, there's something radically different. Sorry, had to use the pun there. But there's something very different, truly, about these denominators. And what is it? Well, you've got things being added or subtracted. The very bottom one that you're going to try on your own is an addition one as well. This is a completely different situation. If we were to multiply, so what's different here is you've got two things added or subtracted in the denominator. So if we were to try to rationalize by taking that 5 radical 2 or 5 plus radical 2 and say, okay, that's what's in the denominator, let's multiply that by radical 2, because that's been our method before. Okay, will this take care of it? Well, no, because you would have to distribute and you'd end up with 5 radical 2 plus radical 4. It would get rid of this first one. It would become 5 radical 2 plus 2. So this one would become a regular number, but now all of a sudden you still have a radical 2 to deal with. So that didn't work, to multiply by the radical 2. So then you might think, okay, well, what if I multiplied by exactly what I see here? So again, we have the denominator of 5 plus radical 2. So the question is, how do we rationalize when you've got things being added in the denominator? So let's try multiplying by exactly what we see, the 5 radical 2. Well, in this case, you're going to have to FOIL, which means, you know, your first times first turns out okay. That's 25. 5 times 5. Your outside times outside, there's a 5 radical 2. Your inside times inside, there's another plus 5 radical 2. And a last times last, which is going to be a radical 2 times radical 2. So you can kind of see what's going to happen here is your 25 is fine. It's going to be 25. But your 5 radical 2 and 5 radical 2, those combine together to give you 10 radical 2. The radical 2 times radical 2 becomes radical 4, which does just become 2. So in a sense, you were able to take care of 2 of it. You've got now 27 plus 10 radical 2. So the 27 is okay, but again, right here, you still have a radical 2 in the denominator. So we've not rationalized the denominator, we just made it look different. What are we going to do? Well, what we would like is we want this part gone. Okay? And if you remember, there was something that we could FOIL, and every time we FOILed it, the outside inside turned out to be opposites. One would be plus, one would be minus, and they would cancel each other out. And if we could get that to happen, then we'd just be left with these outside nice numbers, because you'd have a number times a number, radical times a radical, and you'd be back to what you wanted, a rationalized denominator. So what we want to do actually is take that denominator. So this one doesn't work, just multiplying by the radical. This one doesn't work, multiplying by both pieces, exactly what you see. Instead, we want the denominator to be multiplied by the opposite of what we see. Here's the 5 plus radical 2, and we're going to multiply it by 5 minus radical 2, because the 5 times 5 will give us that nice number. The radical 2 will give us that nice number. But here we've got a plus 5 radical 2 and a minus 5 radical 2. Those will cancel. And this piece right here that we're going to multiply by is called the conjugate. Okay, so when you have two things being added or subtracted, because subtraction is really adding the negative here, we're going to rationalize. In other words, create nice whole numbers on the denominator by multiplying by the conjugate. And this is a fancy way of saying we're going to multiply by exactly what you see, except we're going to change the sign in the middle. So in this case, we're going to multiply by top and bottom. Again, we want it to match, because when we match top and bottom, you're really just multiplying by a value of 1. So it doesn't change what this equals, it just changes the look of it. Okay? And that's the whole point. We're just changing the look so that we can express it in terms of what a fraction truly means. So in this case, you're multiplying by 5 minus radical 2, the conjugate. Now remember, when you multiply, you are foiling. When you have 2 pieces times another 2 pieces, you're foiling. So you get this first times first, or 5 times 5. You get the outside times outside. Do this in a different color here. You get outside times outside, which is going to be a minus 5 radical 2. You get your inside times inside. There's your plus 5 radical 2. And you also get your last times last, which is your, I'll do that down here, which is your radical 2 times radical 2. So your 5 times 5 on the bottom, this is still just the denominator here, is going to be 25. Your minus 5 radical 2 and your plus 5 radical 2 cancel. That was the whole point of using the conjugate. We wanted to cancel those pieces. And then our radical 2 times radical 2 is radical 4, or just plain 2. So we just end up with 25 plus 2. That is our new denominator. It's our rationalized denominator. So in this case, we've got 1 times 5 minus radical 2 on the top, which is just 1 times anything, doesn't change it. So you just end up with 5 minus radical 2 on the top, because we were multiplying by 1. And on the bottom, we have our 25 plus 2, or 27. And so that's the rationalized version of that one. And what's different about this next one that we're going to tackle, let's see if we have it on screen. I think I'll pause the video and we'll start that on the next one.